No Italian gorgonzola factory starts with worms, because worms have no role in making this cheese. And any worm cheese story is a mix-up with entirely different products like Sardinia's Casu Marzu. Gorgonzola is a controlled fermentation process built on milk chemistry, specific starter bacteria, and blue mold spores. And the veins are engineered by oxygen management, not by insects. Production begins with milk receiving, where tanker loads are sampled for antibiotics, total bacterial count, somatic cell count, fat-to-protein ratio, and freezing point to detect dilution. Those numbers matter because gorgonzola is a high-moisture blue cheese, and small shifts in protein quality change curd strength, whey drainage, and the final creamy or crumbly texture. The milk is chilled fast and held in insulated silos with gentle agitation to prevent cream separation without damaging fat globules. Most large facilities standardize the milk by adjusting fat content, because consistent fat controls body and mouthfeel, and it also sets the substrate for lipolysis during ripening. Depending on the plant and the market, milk may be pasteurized for safety and consistency. Or processed under tightly regulated conditions if raw milk production is used. With stricter hygiene requirements and rapid acidification targets, either way, everything downstream is built to give beneficial microbes a head start and keep spoilage organisms from gaining ground. The milk is warmed to precise inoculation temperature in jacketed vats using hot water or steam heat exchangers, with PID control to prevent overshoot that would weaken rennet activity. Starter cultures are added next, typically mesophilic lactic acid bacteria that convert lactose into lactic acid, lowering pH in a controlled curve. That pH curve is a central control parameter because it governs mineral balance in the casein network, which determines whether the final cheese will be more dolce and creamy or more Conti and firm with sharper flavor. Blue mold spores are introduced early, not late, and the factory treats them like an ingredient with a dosage rate. The mold used for gorgonzola is commonly Penicillium glaucum, sometimes alongside strains selected for aroma and vein pattern, and the spores are dispersed to avoid clumping that would create uneven blue pockets. At industrial scale, spore addition may be done as a dry powder metered into the vat or as a liquid suspension injected in line. And the goal is predictable colony density across thousands of wheels. rennet follows. And here the plant switches from fermentation control to enzymatic coagulation control. Rennet enzymes cleave capicasein, allowing casein micelles to link into a gel that traps fat and water. The coagulation time is measured, logged, and used as a real-time indicator of milk behavior. Because seasonal feed changes and herd conditions can shift coagulation speed even when lab specs look normal. When the curd reaches the right firmness, it's cut, and cutting is a mechanical operation that sets moisture content more than any later step. Harps or rotating knives slice the gel into curd grains, and grain size is chosen to retain relatively high moisture compared to hard cheeses. Smaller grains release more whey and make a drier, sharper cheese. Larger grains keep more whey and produce the softer texture associated with Gorgonzola dolce. After cutting, the vat is stirred gently to firm the curd surface and control syneresis, which is the curd's natural tendency to expel whey. Temperature and stirring intensity are tuned to avoid buttering off, where fat escapes into whey, reducing yield and creating greasy defects. Many plants monitor whey clarity and fat losses with inline sensors or rapid lab checks. Because yield loss at this stage scales into tons over a production week. Draining separates curd from whey, and the whey stream is itself a measured output because it becomes whey protein concentrates, lactose, or animal feed depending on the facility. The curd is transferred into molds, often cylindrical hoops sized to the standard wheel dimensions, and this is where Gorgonzola begins to look like Gorgonzola. Some producers use a two-curd technique, layering curds of slightly different acid development to encourage internal openness, which later becomes the oxygen pathway for blue veining. Pressing is minimal compared to hard cheeses, because the factory wants an internal structure with small openings rather than a tight closed paste. The wheels are turned repeatedly to distribute moisture and equalize shape. And automated turning machines reduce labor while improving uniformity. Each turn also prevents excessive whey pooling, which could cause sour pockets or uneven mold development. Salting can be dry salting, brine salting, or a combination, and it's one of the most powerful control tools in the entire plant. Salt slows acidification, regulates enzyme activity, controls water activity for safety, and influences rind formation. In brining, conveyors move wheels into high salinity tanks for a defined time based on weight and moisture. And brine is filtered and monitored for pH, microbial load, and salt concentration because dirty brine becomes a contamination vector. In dry salting, salt is rubbed onto the surface over multiple days, allowing more nuanced control of rind and moisture gradient. From here, the factory shifts into managed ripening, which is essentially controlled microbiology and controlled oxygen. Wheels move into temperature and humidity-regulated rooms, where airflow is engineered to avoid condensation while still removing excess surface moisture. Humidity that's too high encourages unwanted surface growth and slime. Too low cracks the rind and dries the paste, blocking proper blue development. The signature step that creates the blue veins is piercing, and it's pure engineering. Stainless steel needles or multi-needle machines punch channels through the wheel, introducing oxygen deep into the paste. Penicillium is aerobic, meaning it needs oxygen to grow. So those needle tracks become growth highways that spread blue-green veins from the inside out. Piercing patterns, needle diameter, and timing are selected based on desired vein density and texture. And factories adjust these parameters for dolce versus picante styles. As ripening continues, the cheese becomes a biochemical reactor. The starter bacteria and secondary microbes produce acids and aroma compounds. While molds and enzymes break down proteins and fats, proteolysis softens the curd, turning a firm gel into a creamy paste by cleaving casein into peptides and amino acids. Lipolysis releases free fatty acids that the mold converts into methyl ketones and other volatiles that define the characteristic. Blue cheese aroma, asterisk pH doesn't just drop and stop. It evolves during ripening because mold metabolism can raise pH locally by consuming lactic acid and producing alkaline compounds. That pH shift changes texture and also influences which microbes can survive. So the ripening room is managed to keep the process stable and to prevent late blowing or off odors.
Yes, I'd like some of the Granarolo, please.
Many plants use routine core sampling to measure pH, moisture, salt, and vein development. And those data points feed back into decisions about piercing timing, room conditions, and final aging length. Time is the differentiator between mild and intense Gorgonzola. Gorgonzola dolce typically ripens for a shorter period, maintaining higher moisture and a creamier structure, while Gorgonzola picante goes longer, allowing more proteolysis and lipolysis to concentrate flavor and firm the body. Longer aging also increases salt equilibration and moisture loss, which is why airflow and humidity control become more critical as the wheels sit. Industrial ripening rooms run like climate chambers. Refrigeration systems hold temperature within a narrow range. Humidifiers or steam systems stabilize relative humidity. And air handling prevents dead zones where one rack matures differently from the next. In high-throughput plants, RFID tags or barcode systems track each wheel's make date, salt schedule, piercing date, and room history. Because traceability is a legal requirement and also a quality tool when defects appear. Food safety in blue. Cheese is managed through multiple hurdles rather than a single kill step. Acidification reduces pH. Salt reduces water activity. And controlled refrigeration limits pathogen growth, while strict sanitation keeps post-process contamination low. Facilities implement environmental monitoring focused on listeria control, especially in ripening and packaging areas where moisture and organic residues can support persistent contamination. Cleaning is weak. When wheels reach target maturity, they're trimmed and cleaned, and any rind defects are evaluated because rind integrity affects shelf life. Some products are sold as whole wheels, but most are portioned into wedges or blocks. And cutting equipment is designed to minimize smearing of the soft paste. Wire cutters and guillotine knives reduce compression compared to saw blades, preserving the vein pattern and preventing paste from sticking to the blade. Asterisk. Packaging is engineered to balance oxygen control with mold stability. Too much oxygen can drive continued mold activity and flavor drift. Too little can flatten aroma and change texture over time. Many products use breathable wraps or films with controlled gas transmission rates, while others use modified atmosphere packaging to slow microbial changes and extend shelf life. Seal integrity is verified with inline detection systems, because a leaky package dries the cheese and accelerates oxidation.
This is incredible. The gorgonzola is perfectly balanced. Look at that honey just melting in. The gorgonzola with the pear is incredible.
Every batch is checked against compositional specs, typically moisture, fat and dry matter, salt content, and microbiological limits. Sensory panels or trained graders assess aroma intensity, bitterness, ammonia notes, and texture defects like graininess or excessive runniness. The goal is repeatability because consumers expect the same spreadability and flavor every time. Even though milk is a living raw material that changes with seasons, efficiency in a modern gorgonzola plant comes from controlling variability at the earliest steps and minimizing rework later. Standardizing milk reduces batch-to-batch drift, automated cutting, molding, and turning cut labor while improving uniformity. Data logging across pH, temperature, salting time, and ripening conditions allows continuous improvement. Because a small optimization in moisture retention or yield per wheel saves massive volumes of milk over a year, the defining high-tech element is that the blue veins are not random. They're manufactured by designing the cheese's internal oxygen pathways and microbial environment. The factory isn't creating mold and hoping for the best. It's building a controlled habitat where specific organisms dominate. Specific enzymes work at specific rates, and the final texture and flavor land inside a narrow target window. That's how raw milk becomes a stable, sliceable, consistently veined gorgonzola through precision fermentation, precision climate control, and a process that turns microbiology into an engineered product.